Okay, so we are now on to part B. We've got a second equation, x equals y squared. First thing we want to do is graph this. So let's pick some values for x and y and put them in here. So let's let x equals 0, 1, 2. Let's see what we get. If x is 0, y must be 0. If x is 1, so square root, that would be a plus or minus 1. So that gives us here and here. Actually, this would not work. Let's use numbers that I can see will work. If x is 4, 4 equals y squared, take the square root, that gives us a plus or minus 2 for y. So this is a parabola on its side. Okay, so that's what it looks like. Checking for x-intercept and y-intercept. So x-intercept, that means we're going to replace the y, replace the y with 0. So let's do that the correct way. So wherever there was a y, I'm putting 0. And then I'm trying to, that's still not right. Sorry, guys. It is x equals y squared. So x equals 0 squared, x equals 0. That tells me my x-intercept is at 0, 0, which we can see already. And again, we'll do the same thing with the y-intercept. Even though we know what the answer is going to be, I just want you to see the process. When I'm looking for the y-intercept, I'm going to replace x with 0. So 0 equals y squared. To solve for y, I take the square root. So I get y equals 0. So my y-intercept is at 0, 0. Okay, let's check for our symmetry now. Let's check for the x-axis, which means, again, if we're checking for the x-axis symmetry, I'm going to change the y's. So opposite of what's here. So I'm going to replace y. Anywhere there was a y, I'm putting a negative y. So x equals negative y squared. Negative y times negative y is positive y. So that equals x equals y squared. That is what we started with. So it is symmetrical about the x-axis. Okay, let's come over here. Let's check for symmetry around the y-axis. And here, if we want to check for symmetry on the y-axis, I'm going to be changing the x's. So wherever there is an x, I'm going to be putting a negative x. So negative x equals y squared. I want to try and make this look like our original equation. So the first thing I need to do is multiply both sides by negative 1. I get x equals a negative y squared. Now notice that negative is not getting squared. Okay, we've got to be very, very careful with these negative signs. So negative y squared is not the same as y squared. So not symmetrical around the y-axis. And then let's check for the origin, for symmetry around the origin. When we're checking around the origin, we have to substitute negative x for x and negative y for positive y. So this will become negative x equals negative y squared. And notice I'm putting the parentheses around the negative as well as the y, because I've substituted negative y for the original y. And now let's see if we can simplify this. So negative x we will leave alone. Negative y times negative y is positive y squared. If I want to try and make this look like the original equation, I need to have a positive x on this side. So that means multiply both sides of the equation by negative 1. So notice y squared already exists, and then I'm multiplying it by the negative. It's not that the negative will get squared. So I have x equals negative y squared. That negative does not get squared, thus this is not symmetrical about the origin. Little tedious, but it's not difficult. We just have to remember what it is we're substituting. Okay, next one we have y equals 1 over x. Okay, We can do this. Hopefully we remember that is the rational function, the parent function. And again, if we put in values, we could get this a table. But I'm going to go ahead and just draw this one in for you. So it looks like this. Remember, rational functions have asymptotes. Hopefully that word is familiar. First thing I want to do is try and find the x and y intercept. So x-intercept. To find the x-intercept, we replace y with 0. So 0 equals 1 over x. If I'm trying to solve for x, I need x out of the denominator, so I would multiply both sides of the equation by that denominator. So on the right-hand side, I get the x's would cancel, so I'm left with 1. The right side, x times 0 is 0. Well, 0 does not equal 1. This tells us there are no x-intercepts. So no intercepts. No x-intercept. Okay, and our graph shows us that. But again, let's do the y-intercepts mathematically. To find a y-intercept, we're going to replace the x with 0. Ooh, can we divide things by 0? This is undefined. We are not allowed to do this. You can never divide by 0. So no y-intercept. Okay, so we've got our intercepts that there are none. Now let's look for our symmetry. Okay, so looking for symmetry, if we look at this, just eyeballing it, it looks like it's symmetrical. But let's figure out what type of symmetry it actually has. Remember to check for symmetry about the x-axis. That means we're changing our y's. So it's going to be negative y. Does that equal 1 over x? And again, the first thing we need to do is try and use algebra to get this equation with the y by itself. So multiply both sides by negative 1. We get y equals negative 1 over x. That is not the same as positive 1 over x. So this tells us it is not symmetric about the x-axis. Okay. Let's check for y-axis. I would have guessed it was symmetrical about x-axis, but let's just check. So for our y-axis, we're going to replace the x with a negative x. So we'll have y equals 1 over negative x. Well, 1 over negative x is the same thing as negative 1 over x. It doesn't matter if you put the negative in the numerator or the denominator. Either way, that's not the same as positive 1 over x. So it is not symmetrical around the y-axis. Okay, we're kind of running out of things here, aren't we? Let's check for the origin. Is it symmetrical about the origin? So when we're doing this, we replace both the x and the y with negative. So negative y equals 1 over negative x. Okay, and I'm going to rewrite this with the negative in the numerator, as that's where we typically put it. And the first thing we do to get this equation looking like the other now is multiply both sides by negative 1. And when we do that, we get y equals 1 over x, which is good. That is our original equation, so it is symmetrical about the origin. Okay, so on all of these, we're going to be checking for symmetry around the x-axis, the y-axis, and the origin. Okay.